Welcome to another one of my SAT mathematics videos. In this video, we're going to explore some of the basic concepts that come in geometry for the SAT. Angles, triangles, and similarity, namely. When it comes to angles, there are just a few rules you need to know. Angles on a straight line, they always sum up to 180 degrees. Angles around a point, so this plus this plus this plus this is 360 degrees. Alternate angles, so angles that come in this Z sort of thing or this Z are equal, so this and this is equal, this and this is equal. For this condition, there are just two conditions you need to make sure of. Firstly, these two lines do need to be parallel, and this line, by the way, is called the transversal. Vertically opposite angles, so if two straight lines intersect, the opposite angles are equal, so this and this is equal and this is equal. And finally, in similar conditions where we have two parallel lines and a line cutting through or a transversal, the boxed angles called corresponding angles add up to 180. This plus this is 180. This plus this is also 180. And that's pretty much all you need to know. So let's dive into one of the most complicated questions you can get regarding all of these types of angles, and I recommend you solve these yourself and then look at how I'm solving them so it's easier to follow. If you have any problems, leave a comment and I will be happy to walk you through, right? Now your first realization in this question needs to be that these are angles around a point. So therefore x plus y plus z plus 90, this box kind of thing represents that this angle is 90, is equal to 360. Now subtracting both sides by 90, we know that x plus y plus z is 270 degrees. Now we just solve it as a normal ratio question. So there in the ratio 3:5:2. This means there are 10 parts to it, out of which x is 3 parts. So 3 by 10, so x is, in other words, 3 by 10th of 270, which is 81 degrees. Now note that this diagram is not to scale, so just pay attention to the numbers over here. That being said, let's move on to triangles. There are really only 4 things you need to know about. The angles sum up to 180 within the triangle. The area is half of the base into the perpendicular height. There is a practice question I have that will help you understand what I mean by perpendicular height slightly better eventually. So we'll just wait to explain what exactly perpendicular height is until we get when I get to that question. The sum of the two smaller sides needs to be greater than the length of the larger side. In other words, a plus b needs to be greater than c. This means 3, 5, and 7 is a valid triangle because 3 plus 5 is 8, which is greater than 7. But 1, 2, and 3 cannot make our side lengths cannot make a triangle because 1 plus 2 is 3, which is equal to 3, but not greater than 3. And I really recommend you think about why this is the case very intuitively. It is pretty easy to understand why this is, and leave a comment about why you think that in order for 3 numbers to make a triangle, the sum of the 2 smaller numbers has to be larger than the largest side. The first, I'll reply to the one that gets it correct first, I guess. And yeah, that's that. So in this, you're not going to get really tough questions. They'll give you 4 options of 3 numbers and ask you, okay, right, which one of these can make an actual triangle, right? So you're going to look at for which of those options that they have given is the sum of the 2 smaller numbers greater than the largest one. And finally, for any right triangle, so any angle with a right angle or 90-degree angle, a square plus b square is equal to c square. In other words, the squares of the 2 smaller sides, the sum of the squares of the 2 smaller sides is equal to the square of the hypotenuse, which is the longest side, and the side that is directly opposite the 90-degree angle. And let's just quickly jump into the last bit of theory we need to look at before the questions. So similarity, if two triangles are similar, all their angles will be equal. So this angle and this angle is going to be equal, this angle and this angle is going to be equal, and this angle and this angle is going to be equal, and all these lengths are going to be scaled up by the same factor. So we see 12 is 2 times greater than 6. This means 9 is 2 times greater than this side. So this side has to be 4.5, and the hypotenuse here is 2 times greater than x, right? So if we had to solve this question, we know that the 2 is the common factor. Using Pythagoras Theorem, 9 square plus 12 square, which is 225, we can get the hypotenuse of the larger triangle is 15. Now 15 is 2 times x, therefore x is 7.5. And that is how you would solve a question in similarity. Very easy. And now let's just look at general questions. So this is actually one of the hardest questions you can get from geometry and in the SAT. So it always helps if you draw a figure. So we know we have an equilateral triangle, so we have labeled each of these sides A and A, suggesting that they're all equal, and we know that the altitude over here is 8, right? Here is probably where I'll explain to you what I meant by perpendicular height earlier. But for the first thing you do need to realize is this is a right triangle. Therefore, 8 square plus a by 2 squared, because this altitude divides both sides by divides this line into equal parts. So this is a by 2 and this is a by 2. So 8 square plus a by 2 square is equal to a square. I've just written it slightly differently there. Therefore, a square minus a by 2 square is equal to 8 square, just Pythagoras theorem. So that gives you 3a squared by 4 is equal to 64, and eventually doing the math, you get a is equal to 9.24 centimeters, or 9.24, yeah, we have units here, so 9.24 centimeters, right? Now that is the side length. Once you have the side length, the area of an equilateral triangle is half into base into, the area of any triangle is half into base into height, right? Now height needs to be perpendicular height. So what that means is I can't multiply a into a just because it's a two sides of height. Perpendicular height means the height where there is the height that is perpendicular to the base. We see that this altitude over here is perpendicular to the base. This is a 90-degree angle. Therefore, our height over here will be 8 and our base can be 9.24, which is a. Multiplying them together and calculating the area of the triangle, we get 36.96, and therefore the question is solved, right? This is another question. Pause the video, try and solve it yourself. I'm going to discuss the solution right now. So the first thing you need to realize is that angles in a triangle sum up to 180 degrees. Now the best way to approach these kind of questions is try to find, even though they just want you to find x, which is this whole thing, try and fill as many angles as you can, and you will almost always inevitably get the reach and find the x. So the first thing that looked easiest in the previous question was finding this, because we already have a 90-degree angle and a 32 angle here. So we know that angles in a triangle sum up to 180 degrees, so we could pretty easily find that one, which was 58 doing the math. The second thing I could realize is, hey, I can fill this next, right? So that's what I'm going to do. Vertically opposite angles are equal, so this 2 has to kind of be 58. Now, once we have this, we have pretty much, so we can realize we have pretty much solved the question, because once again, angles in a triangle sum up to 180, we have this as 41, this is 58. The sum of 58, 41, and x have to be 180, and therefore we find x to be 81, and we have solved the question, right? This is another kind of question where perpendicular height becomes important. So in this question, we want to find the area, the shaded area, where DC is 10 and BC is 25. So first thing we need to be clear, and we see that E is the midpoint of AB. So what that means is that AE is equal to EB, which is equal to half of AB, or half of BC, because this and this are equal, opposite sides are equal in a rectangle. E is the midpoint. This means EB is half of AB, which is half of 10, which is 5. The second thing you need to realize is that BC and AD are equal because they're opposite sides in the rectangle, so they're equal in length. So AD is also 25 centimeters, even though it's not mentioned in the question. Now the area of DB is half into base into perpendicular height, right? So now over here, you can see that we do not have any clear perpendicular height, so there is no altitude rising that is 90 degrees or perpendicular to the base EB over here. So at this point, what we can do, we note that AD is perpendicular to EB and runs through the whole shape, right? So in this case, we can take AD to be the perpendicular height over here. So even though it is not illustrated in the question, we can illustrate it within the triangle. We see that AD is perpendicular to EB and runs the course through the triangle, and therefore we can take AD as the perpendicular height. So therefore the area of DEB is half into EB, which is the base, and we can take perpendicular height as BC or AD, they're equals, we can take either. We can substitute the values and then we get area of DEB as 62.5. Simple question, there was nothing to sweat about, we noticed. And right, that being said, I think we're going to look at what we're going to cover in the next video, that is geometry 2, but this time we're going to look at quadrilaterals, circles, and 3D shapes. With that, thank you guys, do have a great day. See you in the next video.